Alright guys, today we're going to talk about complex fractions. So up to this point we have talked about multiplying and dividing rational expressions. We've talked about adding and subtracting. Well, the complex fractions we're going to look at today are going to combine those operations. Okay, so we have looked at a simple complex fraction in the past where we've had a single fraction over a single fraction and it was just division. But now we're going to have addition along with it. So if you look at number 1 here, notice the numerator is simply that one fraction. We really like the way the numerator looks. But the denominator has 2 fractions. So the first thing we need to do is we need to take care of this denominator. So to do that, we are going to try to add them together to a single fraction. So remember, we need a common denominator. So if we look here, the good news is that our denominators are already simplified. X plus 4 and x cannot be simplified anymore. So we already have an x plus 4 on this first one, but we need to add on to it an x. We're missing the x from the second fraction. And on this one over here, we already have an x, but we need the x plus 4. So our least common denominator is going to be x times x plus 4. Now, notice up top here we have a 1 and we have a 2. Because we added the x on the bottom, we have to multiply the x on top. Because we multiplied x plus 4 here on bottom, we have to multiply x plus 4 on top. Now, please do not get canceling happy. Don't do that. Remember, the reason we did that was so that we could have the same denominator. So we keep the denominator and we're going to leave it factored. Some of you have gotten to a habit of multiplying it out. Please do not multiply it out. Leave it factored. Otherwise, you're going to do more work on yourself. Now, the top, we do have to multiply. 1 times x is x. Over here, we have 2 times x plus 8, which would give us 3x plus 8 over x times x plus 4. Again, do not multiply, you're just going to do more work. So now what we have is we have a more simplified version of our complex fraction. So I am looking at 3x plus 8 to see if it simplifies, and it does not. And we're going to leave this as x times x plus 4. Do not do extra work. Because remember that this guy right here simply means divide. So this is going to become 5 over x plus 4 divided by 3x plus 8 over x times x plus 4. And notice everything is actually already factored. This is why I don't want you to multiply things, because both denominators are factored completely. 5 is factored, 3x plus 8 doesn't factor. So now we are going to change this to multiplication. So 5 over x plus 4 times the reciprocal. X times x plus 4 goes on top. 3x plus 8 comes down to the bottom. And now we can cancel out any factors that are alike. So we can cancel out this x plus 4. And that looks like that's all we can cancel. So we would have on top 5 times x over just 3x plus 8. Now we do need to include what x cannot equal. So to do this, we have to go back to the original problem. So we're going to have to go back to this denominator and this denominator. So in this case, we have x cannot equal -4, because x, if you put -4, that would equal 0. Here, x cannot equal 0, and then x plus 4, that's the same one. But then we also have to look at the reciprocated fraction. So 3x plus 8. Now that one's not quite as easy, so if you get stuck, remember all you have to do is set it equal to 0 and solve. Okay, and you can always do this if you get stuck. So it also cannot equal -8/3. So there are 3 values that would not work for this expression. And there it is. That's simplified. All right, let's try another one. Number 2. All right, this time they weren't quite as kind to us. They gave us 2 pieces that have to be simplified, so a numerator and a denominator. So the first thing I would do is I would actually rewrite this, because I don't like that -4 not being over a fraction. And more importantly, I don't like negatives. So I'm going to change this to plus -4 over 1. And then the same thing on the bottom here, 2 over x plus 3 over 1. Now you might think, hey, Miss Miller, let's just cancel out these 2 over x's. But remember, these I call them my married couples. They're stuck together, okay? It's a sum or difference. They have to stay together. So we can't just start getting cancel happy, okay? We're going to actually have to go about simplifying this down. So I'm going to start with the numerator. So my advice to you is to start with one place and know where you're going. So the good news is the denominators are going to be very easy to come up with. X and 1, the common denominator is 1x. Okay, so this first fraction already had the x. But the second fraction, we have to multiply it by x. Okay, so we're ending up with, remember they're all going to go over x, 2, well that's going to be minus 4x. Now I am going to rewrite this a little bit. I don't like the order of that. I'm going to write that as negative 4x plus 2. And yes, I do see that it factors. I ran out of room though, so we'll come back to that in just a minute, okay? Now, in the bottom, same kind of thing. Looking at the denominators, the good news is again, they're both going to be x. So this was already x, so 2 over x, but we have to multiply the 3 by x to go from a 1 to an x. So that's going to give us all over x, 2 plus 3x. And again, I would rather have it in order. Okay, so now, here's what I have. I have negative 4x plus 2 over x divided by 3x plus 2 over 2. And I would advise you to not try to conserve room on these, like use space, guys, because right here you can actually see the division bar. Notice I've kept it in order so that you can see numerator, denominator, so that you don't accidentally divide the wrong thing. Now, again, this is going to be negative 4x plus 2 over x divided by 3x plus 2. Whoops, I think I changed that. For some reason I changed x to a 2. Sorry about that. So let's fix that little mistake. Hopefully you caught that. If you didn't, make sure you fix it. Now, we are going to want to factor. So this top has a negative 2 as a greatest common factor. So 2x minus 1 over x divided by, now 3x plus 2 does not cancel over x. So now we're going to have to change it to multiplication. So the first fraction stays the same. The second fraction gets flipped over. And then we look to see, okay, is there anything that we can cancel? And notice, yes, there is. Those x's cancel out. You don't have to multiply, guys. You can leave them factored. Negative 2 times 2x minus 1 over 3x plus 2. Please do not distribute. It's okay not to distribute, okay? Now, last thing, we need to look back at our values that don't work. So we're going to go back to our original division problem here. So notice, well, they have the same value, right? So x definitely can't equal 0. But then we also have to look here where we flipped it over. So 3x plus 2, that would be negative 2/3. And again, if you're not quite sure where I got that, just set it equal to 0 and solve. Subtract 2, divide by 3. So this would be our simplified expression with our excluded values. Okay, so number 3. Okay, so number 3. Again, I really like that the numerator doesn't have to be simplified. So what I would like for you to do is I'd like you to go ahead and try to simplify this denominator on your own. And when you're ready, turn the video back on. All right, you should have gotten 3x plus 7 over x plus 5 times x minus 3. And again, please do not multiply them out. Okay, so now we have 3 over x plus 5 all over 3x plus 7 over x plus 5 times x minus 3. And it doesn't matter which order you put them. You can put the x minus 3 first or the x plus 5. So again, remember that this is division. So this right here is simply going to equal 3 over x plus 5 divided by 3x plus 7 over x plus 5 times x minus 3. So we're going to look to see does anything factor. And this is the reason we don't multiply things out and do extra work, because both denominators are already factored, and 3x plus 7 cannot be factored any further. So we're going to change this to multiplication. So keep the first fraction. We're going to use the reciprocal of the second fraction. And then again, we're going to look and see, is there anything in common? And look at that, x plus 5 and x plus 5 will cancel out. And we're left with, on top, 3 times x minus 3 over 3x plus 7. You do not have to multiply it out, and please do not divide these 3's. Okay, you cannot do that because 3x plus 7, they're a couple, they got to stick together. So x cannot equal, again we're looking at our original division problems. So notice they have x plus 5 in common. So that would be negative 5 and positive 3. It doesn't matter which one you write first. And then of course we have to look at the reciprocal value. So 3x plus 7, if I let that equal 0, 3x equals negative 7, so x equals negative 7/3. So there we go. And that right there would be our answer.